All right, we're starting our second video for the week where Tara just walked you through an introduction to the tidyverse and has been working with manipulating some of our surveys data using the select and filter functions. And so we're just going to pick up there and continue on manipulating data. So in case you're not there already, we are going to load in our tidyverse library and make sure that we have used our read_CSV function to read in our surveys data that lives in our class project. And so I'll dive right in with the first function that we're going to be talking about today, which is mutating or creating, a new object or variable in your data. And so now that we know kind of how to select different columns and filter the data based on different conditions, you might want to then start actually changing the data itself. And this is where mutate comes in. So a reminder of our data structure, we can use this str function, get a feel for the different columns that we have and the different data types that they have. And so looking at these data, we have a bunch of numeric or continuous variables. And let's say that we want to make a conversion of one of these columns. So weight in these data are measured in grams as the weight of the rodent. And so let's say we wanted to create a new variable that is the weight of the rodent, but in kilograms. And the basic logic of how we do this, harkening back to kind of week 1 and 2, is talking about vector math, and just that we can perform mathematical operations on vectors, and columns in data frames are just vectors all kind of mashed together. And so if we look at our weight column in our surveys T data frame and divide by 1,000, that would be the conversion from weight in grams to weight in kilograms. And when we just run this line of code, we get the converted output in our console. But what we're going to do with mutate is learn how to put that directly into our data frame. So append a new column into our surveys T data frame. And so let's use the pipes that Tara just talked about to mutate ourselves a new column, weight in kilograms. So we are going to start off with our surveys T data frame, and then we're going to use that pipe. So that percentage sign. Tara mentioned this, but on Macs, there is a shortcut, which is Command plus Shift plus M to get this pipe symbol pretty fast if you memorize those keyboard strokes. So we're taking our surveys T data frame and we're piping it into our next function, which is going to be mutate. And so the way mutate works is inside mutate, you will open up your parentheses. You'll then give the new column name on the left-hand side. So new column name, we'll name this whatever we want. We'll use a single equals sign here. And then on the right-hand side of the equal sign is going to be our mathematical conversion, or whatever it is that you want to do to an existing column. So edit to existing column in order to create this new column on the left. And so if we're looking at this conversion we just made above, we just want to divide the weight column by 1,000. So we're going to call this weight in kilograms. So weight underscore kilograms is going to be our new column name, equals. And then we want to convert weight by dividing it through at 1,000. Note that I don't need to specify where weight comes from here. As Tara talked about, the point of these pipes is that you can kind of have this streamlined flow, working flow. So with pipes, don't need to specify data frame. It knows intuitively that you're talking about weight inside of surveys T because of this pipe. So if we run this line of code, surveys piped to mutate weight in kilograms, it's a little hard to tell exactly what happened just given our the output that prints into our console, because typically when you mutate a new column, it will append that column onto kind of the rightmost or furthest side of the data frame. So we can't read it out in our console. We only get a few hints. And that's that we know from our summaries up here, or if we were to look at the dimensions of surveys T, we only have 13 variables. But when we print it out in the console, you see that we now have a 14th column. And so this is kind of always important to remember. I think when folks first start out coding, they want to know, like, I made this column, why can't I access it now, right? If I go into surveys T and then I want to find weight kilogram, it's not there. And this is because it's really important to make sure that you are either overwriting your existing data frame or writing a new data frame that with a new name so that you can see the difference between your two objects. So I'm going to say, make sure to name a new object. And so here we take the exact same line of code, but we use our assignment arrow to call this surveys_2. And now we have a new object in our environment, and it has that 14th variable. So we can call surveys2 and then find that weight kilogram now lives in our new surveys object. So that's sort of an important first step, is that we can now, with mutate, make new columns. And we're going to come back to this next week, and it's going to become a bread and butter as you learn to manipulate your data. But the second function or group of functions that we're going to learn together is the group by and summarize set of functions. So we have learned that, in addition to mutating, we can also use mathematical functions to summarize our data. So we may have already tried a few of these out. For instance, if we just call the mean function, we could take the mean of one of our data columns. So if we do surveys_T $weight, we can look at the mean. But you'll notice in our console, we get an NA. And this is something I don't think we've really talked about before. So, we can use math functions to get summaries, but we need to remove the NAs. And we learned how to remove NAs from our data using indexing and subsetting last week, and Tara talked a little bit about how to filter out NAs, I think, in the last video. But there's a second way of removing NAs within a function. And that is using this argument that exists in a lot of different functions, which is rm.na equals true. And this is one of those dreaded arguments that kind of comes in the ... of the help file. So for instance, if we look at the mean help file, this argument is not going to be specified there. It says all you need to put into the mean is an X argument, which is some data, and then ... You might be able to have some other things in there. But you'll see it actually is built in this next line where it says it has some defaults built in, which is trim equals 0 and na.rm equals false. But if we go into the help file and read what na.ram is, it's a logical value indicating whether na value should be stripped before the computation proceeds. So this is a really important one. So if you're running a basic mathematical function and you see that it's not calculating quite right, it is likely because there are NAs in your data and we can't make that calculation without it. So we can add this na.rm argument and change the default false to true. And note that the full word true turns pink because it's recognizing that it's this logical value. But T also represents the exact same thing in R. So we can calculate mean of weight, na.rm equals true, and now we can see the mean of our survey data. And we can do the same thing using sort of the tidyverse pipe language. And we're going to use this to build on this group by concept. So in the same way, we can start with our surveys T object. We can pipe to our next function, which is going to be the summarize function. And so summarize is a pretty powerful function, but it's usually kind of an outer wrap to some inner commands. And it's inside this summarize function that we can, again, call upon something like a mean, or it could also be something like max. I mean, a whole range of mathematical functions could go in here. But let's say we want to find the max of our weight and make sure we include that na.rm equals true. Now, granted, we could filter out our NAs above this and have it filtered in an NA-less weight where we wouldn't need this na.rm equals true, but that's sort of your choice as you work through your coding style. So this should give us, I think, the exact same output, except in a small data frame where we've fed in surveys to summarize and we've asked for the max weight in our data. But oftentimes what we want to know as scientists is not just the overall average or overall max, but rather we want to know different summaries based on particular groupings. So what species, weighs the most, and what year did something weigh the most? What's the difference between sex? All of these questions are really common. And so this is where we layer in the group by function as a way of kind of combining and maximizing this kind of pipe tidyverse structure to summarize data. So let's say we want to find not just the mean or average weight of our whole data set, but let's say we want to divide it up by sex. So we have male and female rodents in our data set. We're going to start again by having our surveys T data table pipe through. But here, before we summarize, we're going to tell R what it is that we want to group by. And we're going to do that with the function group underscore by. And then inside parentheses, here we can list all of the different columns by which we want to group our data. So in this case, I've asked the question, what is the average weight by sex in our data? And so I'm only going to group by sex. I will then pipe again. So we're layering on, we're filtering, and we're saying, take surveys, group by sex, and then summarize. In this case, we'll jump back to the mean of weight with na.rm equals true. And our output now is not just giving me one value, but it's giving me 3 values by our groups. Our groups are female, male, and then in some of our data, we have NAs for the sex. So even though we told it to remove the NAs for weight, that didn't necessarily strip out the NAs that exist in sex. So we get 3 different groupings in our group by sex, and then 3 different average weights represented in our data. And so we can do multiple different summaries in here. So we might want to know kind of a whole suite of different summary pieces so we can calculate them all at once. In this case, we could also ask in the same summarize argument, just separated by a comma, and I spaced down just for readability. I could also ask max weight na.rm equals true. And you'll see that it just adds another column to this summary output table, our mean, our max. But you'll notice that the column titles of this output table in our summary are a bit clunky, right? They're exactly what we typed in to summarize, which is pretty unattractive. So we can name our columns internally, just like we did with mutate. We could call this, let's say, mean weight, and use a single $sign to indicate that, and call this, max weight. I said a single $sign, I meant a single equal sign. So now we have named these summary columns. And now I can see again, these have just become a little cleaner. Instead of having the entire length of our summarize argument as the column title, we now have mean weight and max weight as our column title. Right, and so just a few more things. Just like we could do multiple summaries at a time, you can also do multiple group bys at a time. And just like with the summary, we just separate it by a comma. So surveys T underscore T piped into, I just did an accidental keystroke that appears to have opened up my global options, but I don't know what that was. So our pipe, then we can group underscore by, and let's say we also want to group not just by sex, but by species ID. So we could do species underscore ID, sex, pipe, and then ask for the same summary. So let's summarize mean underscore weight again. And now what we see is a bit of a wonky output where we have both species ID and sex, so our 2 grouping columns. So this is every combination of species ID by sex and the mean weight of those. But what's happened here is we must be missing a lot of data, particularly for some species, where in some combination, so you'll think of every species ID by sex combination, there's actually no data at all. So we end up with mean weights as NAs, we end up with sexes as NAs, and that's it's a bit tough to read. And so a few options, we could, maybe start by saying, like, let's clean this up. And a way of cleaning this up is to filter out some of our NAs before we make any of our calculations. And so I might try to do that by, we can go back to Tara's video talking about filters, where before we do our group by and summarize, we actually add a filter line where if we think there are a lot of NAs, or we don't like the NAs in our sex, we only want to know about the groups that are male and female, then we can filter out NAs of sex. So remember, this exclamation sign is not NA. So if you are not NA in our sex variable, we can then just insert that along sort of our piped workflow, and we'll see a much cleaner looking table with now, we can at least read some of the summary outlines. And we may kind of want to do a quick look at something like, what's the smallest mean weight or what's the highest mean weight? And so we can just tack on one more new function to this pipe, which we'll be just kind of experimenting with these. There are loads of tidyverse functions to learn that make data wrangling easy, but we'll just drop one more in here, which is to pipe through to this arrange function. And so arrange is going to do exactly what it seems, which is it's going to arrange them in a certain order. So I can arrange by, and you have to specify the column that you want to arrange it by. So I want to arrange by mean weight. Now, when I print this out, it starts with our lowest value. It does, whereas previously, if you kind of want to think through how did this print this out before, what was its criteria? Typically, R will start with an alphabetical order of its first column. At least the tidyverse will. And so here we're just printing out species ID in alphabetical order related to sex in alphabetical order and has nothing to do with these numeric values. And so you can use a function like arrange to actually be arranging based on the summary variable, the mean weight variable that you're most interested in, as opposed to just kind of a bland output. But you'll notice this truncates at 10. It makes readability in the console easier, but you might want to explore it a little more. So always remember that you can save it as an object. So we could give this a name, call it summary table, and then we can open it up, say, in our global environment and be able to scroll through the whole thing. And you'll notice that that arrange function has maintained, it changed what came out in my console, but it also changed the way that the summary table is organized in my global environment. So this is just sort of a quick look at some of the power of tidyverse and data wrangling, and we'll dive more in class and next week.